Okay, so yesterday you had a few sessions given by my colleagues on what our HPC is and how to connect to it through teleport and VDI. And then you also got a short overview of the European Weather Cloud, and back to HPC, you saw how to use Jupyter Hub to run your things there. And today we are going to talk about how to actually use HPC to its fullest. So, first of all, a few words about the difference between working interactively and using our batch system. So while working interactively, you can just type your command, maybe with some arguments, and then click enter, and the program you are running will be executed on the same machine where you are logged on. You can also send your program to run in the background so that your terminal will be available for you, but it still runs on the same machine. However, the whole idea of HPC is about having multiple machines where you have one or several login nodes to which you actually connect when you want to work on the HPC. And then behind this login node, you also have plenty of computing nodes, which are there to run your heavy-duty stuff. And this is how we are doing it. This is how we are doing it using our batch system. So you log in on the login node, and then you submit your job to be executed on the compute nodes. On our HPC, to orchestrate this whole thing, we are using the system called SLURM, which formerly was standing for Simple Linux Utility for Resource Management. And then it was an abbreviation, and now it's just named SLURM. So what SLURM is doing and what it is, it's a framework to execute and monitor batch work. It is capable of resource allocation, meaning it decides where on which compute nodes your job is going to be executed, and it also decides when it should be executed, because it's not always guaranteed that the moment you submit a task, it will immediately start running on one of those compute nodes. To submit a batch job, you will need to prepare a shell script. And in that shell script, you normally need to put some special directives to describe which kind of resources your job is will be needing in order to run properly. So, as I said, for what we are doing, for what SLURM is doing, we will need to, it will need to decide who can access the compute nodes. It is controlling the limits for your job, the amount of cores, the amount of memory, and so on. It will decide which part of the cluster it will be performed on, and it will also control when the job will run. As you probably remember from yesterday's session, we basically have two major clusters. ECS is the small one, and it's open for all our users, member states, cooperating states, and so on. On that smaller set of machines, we have several different queues, which we call quality of service. So the fractional queue is there to run serial and small parallel jobs. This job will be submitted to fractional node, which you will be sharing with other users. So your job may take 1, 2, 5, 8 CPUs, and the other CPUs at the same time will be used by other users. It has its own limits of wall time, the maximum time your job can run on that node. It has number of CPUs which you define. Default is 1, maximum it can be up to 8 CPUs per job. And you also have a limit of how much memory the job can use. By default, it should be 8 gigabytes and maximum up to 16 gigabytes. You can also submit an interactive job. As you have seen yesterday, we have this ECMWF command that can help us open an interactive session on a remote computing node. And you can have up to 1 of those at the same time, while others you can have more than 1. We also have a long queue for jobs that can last up to 7 days. And we even have a time-critical queue, which you cannot use for submitting your regular tasks, but you can use it indirectly by the time-critical switch, which will be explained later today in the afternoon. On the bigger machine, we have the HPC itself. We have a different set of queues to which you can submit your jobs. We have the fractional, where again you will be sharing the node with other users. We also have an interactive job, and we have the parallel job, parallel queue, which we don't have on ECS. And that basically means that you have one full node or multiple full nodes to be used with your batch job that you are submitting. And you are guaranteed to have the full resources on those nodes, meaning all the CPUs and all the memory of those nodes are completely yours. Now, how do we actually submit such a job? We need to prepare, as I mentioned before, a short or long batch script. It can be either bash or Corn shell. And we need to put a number of directives at the beginning of that script so that the SLURM system will know which resources need to be allocated in order to execute these batch jobs. As you can see here on the right-hand side in red, the SLURM directive starts with hash mark and sbatch keyword, and then double dash and your actual directive with its value. I will probably go a bit in more details later to explain it further. A couple of important things to remember here. The keywords are all in lowercase. There should be no spaces around the equal sign and not anywhere in between the values for those keywords. And you cannot use any variables, bash or corn shell variables within these directives, because those still don't have the value when you just submit your job. And last thing here is that you don't really have to specify any of those. If you just have a normal bash file, you can still submit it and it will be executed with the default values. Now, how do we submit? For that, we use the sbatch command, sbatch. This command gets the script name as a parameter, and if everything works properly, once you hit enter, you will see the message submitted batch job and the job number, so that you can follow the job number. I will shortly show how to follow it. Yes. And of course, if you don't get this message, it will probably give you some error message saying that something is wrong with your script that you are trying to submit. So how do we do it? We connect to the login node, and we do it on the login node. Now, there is also an option to submit a job from the cron. For that, you will have to log in to the cron node, not the login node. Be careful not to define your cron tabs on login nodes. You will have to use the cron node, either on HPC or ECS. So we have HPC cron or ECS cron. That's the node on which you will need to define your cron tabs. You use cron tab -E in order to edit your cron tab. You can also use cron tab -L to review your cron tab, and you just use the normal cron definitions in order to set it up. Yeah, now for a few major keywords that can be used with those hash SLURM directives. So you can set up a job name that describes the name of your job, and later when the job is executing, you will be able to identify it by its name. You can also define the output and the error files into which the corresponding standard output and standard error messages will be written. If you don't specify it, it will just go to some default file name, usually identified by the name of the script you are submitting. You can define the directory into which will be your working directory, where all other things are located, and then the script out, the standard output will also be written. You can, or I would say you should, also define the QoS, the quality of service, or the queue on which you want to run, the time limits, the memory limits. You can even define the email to which the message will be sent upon the successful or unsuccessful execution of your script. And you can specify the billing accounts, because if you run on HPC, it costs you resources that you pay for, not in euros or pounds, but in system billing units. You can also specify the number of nodes, the number of tasks, if it's a parallel task, or number of threads per task, task per node, and so on. Some useful SLURM environment variables that can be used are also shown on this slide. I don't feel like going a lot into the details, but you will find all of them as soon as you need them. So the pipeline goes like that. As soon as you submit your job and monitor it, first of all, in the first seconds or sometimes minutes, you will see that the job is pending. That stage is there in order for SLURM to allocate the relevant resources that your job will need in order to run on the HPC. And as soon as the SLURM system finds the requested resources, your job will be delivered to the corresponding node or nodes, and it will start running. When you check it again, you will see that the status is running. Once the task finished running, you will see another several seconds probably when it's completing. This stage is there because after your actual tasks finished executing, SLURM is still gathering some information and make sure that the storage you were using is deleted, the temporary one, and the number of resources, the amount of resources is calculated and properly reported into the log that you will be receiving at the end of the job execution, and so on. If everything went wrong, then your job became completed. Otherwise, it will be failed, or if you kill it in between, it will be cancelled. Or if it exceeds the amount of time you requested, you will see that its status is timeout, and you might have some others as well. Now, how do we monitor a running job? For that, we have the command SQ. So if you just run SQ command, you will see all the tasks running on that HPC. If you only want to see your own tasks, you should add SQ --me, and then it will only show your own jobs. You can also see someone else's jobs if you specify -L and -U and the username. You can filter the jobs by the names, by the states, by the QoS, and so on. And once you run it, this is the output you should see in your terminal window. So you have the job ID, that's the number that you got when your job was submitted. You can see the job name, you can see the username under which it's executed. Basically, it's your username. You can see the queue into which the job was sent. You can see the job state. You can see how long it's running already and the time limit. And very importantly, you can see the node or the nodes on which this job is actually executed. So if it's a massively parallel job, you will see a list of nodes here. If your job is not running yet, you will see the reason why your job is not running. It may be waiting for the resources. It can have some other reason as well. If you want to terminate your job, you can use the scancel followed by the job ID number. Important thing to mention here is that you can do it even when your job is not running yet. If it's still waiting to execute, you can still cancel it. And if it's running, you can also do that. And of course, the similar flags apply here as well. Yeah, as I said, you can cancel the job at any stage, whether it is waiting, pending, or running. And then, of course, in the status, you will see that the job is cancelled. Why doesn't my job run is a question people sometimes ask. If you see you submitted a job, you check what's going on with it, you see that its state is still pending, and then you can see, for example, priority. It means that someone else has a higher priority and you will just need to wait. Or if you submitted too many jobs, then SLURM will not allow you have a limited number of jobs that can be run simultaneously. So if you keep submitting more jobs, you will be waiting in the queue. Sometimes if the reason is resources, then it means the cluster is full and the resources you requested for your jobs are currently not available. And yeah, as I just said, you have a maximum number of jobs that can run, and you even have a maximum number of jobs that you can submit. So if you keep submitting, you will just get an error. Sorry, you cannot submit any more jobs. You need to wait until all your running jobs are done and all the submitting jobs are run and done. Then you can submit the new ones. You have a few options to actually check and control the number of jobs that are waiting. If you just want to know what are your limits, then these commands can be very helpful for you to understand what are your limitations before you start submitting hundreds and thousands of jobs. Once your job is finished, you can obviously check its logs, the output files, the standard output and standard error, which you can redirect to the same file or to two separate files. But you can also check the statistics of that job with SACCT command. And for that, you have these different options and flags. Now, one thing I shortly mentioned, while working on the big HPC and not the ECS, every job you submit, you actually pay some price in system billing units. You need to make sure that the account has enough billing units to be used. And yeah, of course, the more resources you use in terms of number of CPUs and the runtime, the more you will be paying. So for example, one serial job running for 1 hour will be charged roughly 19 billing units. And if you have a bigger parallel job requesting 2 nodes running for 3 hours, that will be already about 14,500 billing units that you will be charged for such a job. Now, important thing to check, in the log file you get when your job is finished, at the epilogue, you will have this SBU and then the number. So this is how much your job costed you, basically speaking. And of course, very importantly, you can use this link in order to monitor the accounts that you have used and how much SBU you consumed. Now, I need to mention that these numbers on this web interface are not updated as soon as your job is done. It's usually updated once per day at some point at night. So if you run your jobs today, you will only be able to see the total daily consumption tomorrow. And using this link, you can learn more about how our accounting works. You can find the SBU calculator and so on. Now, as I said before, we have, and it was mentioned yesterday as well, we basically have 4 separate clusters, and each of them has its own login nodes. And if you just use the sbatch command, then your task will be submitted to the corresponding cluster. You can work it around by using ECSQ and ECSCancel to monitor and cancel, and ECSbatch to submit your jobs. And the job ID actually indicates on which of those clusters your job is running. So if it's the AA complex, then your first digit will be 1. On AB, it's gonna be 2, and so on. And if you submit your tasks on ECS, then the first digit of your job ID will be 6. If you want to submit a massively parallel task, you will also need to use SLURM command within your shell script. And this command will take care of distributing your task over several CPUs or even several compute nodes, which can be used with or without hyperthreading, with or without MPI, and so on. We will see it later when we get to the hands-on part of our training today. I'm done for now. If you have any questions, please ask now. And if not, we will shortly move on to the hands-on session.